Good morning. The problem with me today is that I don't speak Ukrainian at all. I can just say spasiba, and even then I think it's not the right pronunciation, so I'm really sorry for that. So I hope my English will be understandable. You just let me know if I speak too fast, right? I know I can speak fast, and on top of that it will come with my French accent. Not at all understandable. Okay, you just let me know. Everyone has a problem in my understanding, so just let me know, interrupt me, and I will try to get someone to answer your question or translate what I just said. Is that fine? Okay, thank you. So I said my name is Philippe Trautmann, and I'm the sales director for high performance computing and part the performance optimized data center. So I will talk a lot about servers, offerings, and how HP differentiates today. So I hope it will be an interesting talk. My interest is having a dialogue, right? And have you ask as many questions as you want. Don't hesitate to interrupt me. Some things might not be self-explainable, so just ask questions. I love to be interrupted. Someone will translate that. So what is our goal at HP? At HP currently, we know that there are many types of demands, okay? And when we talk to customers, the demands are not at all the same. So I just would like to check with the audience who is coming from the academic sector, academic research. Almost half of the audience. Coming from the partners, whomever, so all the partners, and the industry. Okay, so that might be one of the issues that we have to face, because the more we go, the more we see that high-performance computing is moving from a pure academic play to a real industry play. Okay? And that's what we are seeing in the trends that we have to face at HP. So obviously we see a lot on the left side here, a lot of CAE manufacturing oriented. So that's really for the automotive, aerospace, electronic design, so all analysis, car manufacturers, ARM, the manufacturers of chips, STMicro, all of these people are using these resources. Then you have the R&D, pure R&D, for life science and pharmaceuticals. That's a very big domain with DNA sequencing, drug design, simulations. This is one of the areas where we see a lot of growth. Now, this one is probably the biggest user of HPC, and this is oil and gas. Oil and gas are having the biggest systems of the industry. And why is that? Because the cost of exploring oil fields has become so huge that the relative cost of simulation, so doing seismic or reservoir simulation, has become the biggest worry of those companies. So if I look at companies like Aramco, like Total, like Shell, like BP, all these guys are running thousands, if not tens of thousands of servers to run their seismic applications or their reservoir simulations. So this is a huge domain for us, especially because they are really number crunching all the data. Another domain is the visualization and media. And we have a lot of activities there, mostly with partners. So we know that we work with NVIDIA. I know that there was an NVIDIA workshop yesterday. And I guess, is there an NVIDIA presentation today again? Yes, okay, so there will be an NVIDIA presentation. So we work a lot with NVIDIA on all those graphic, rendering, and visualization. And finally, one of the most developing domains is defense and finance. Finance, that's for banking, so that's really for credit simulation, Monte Carlo simulations, all these domains, and that's growing quite fast. One of the biggest domains is obviously the high frequency trading, and that's a very specific high performance domain. It is in the middle of HPC, big data, and extremely low latency handling. But the biggest, one of the biggest one is defense. Defense have huge requirements, and that's in terms of, well, secret agencies, dark agencies, which are doing face recognition, which are doing data encryption and decryption, which are doing all these activities. So this is for us one of the largest domains, and if I can just tell you the size, the magnitude at which we are working, one of our customers in the defense area, he has one application, only one application that requires half of a football field of racks. Can you imagine? One application. Half a football field of racks. Okay, and that's not the CIA, right? So it's another agency. Okay, so that's just to give you the kind of magnitude of the problems which we have to address with HPC today. So now let's move on to what HP can provide there. What we are very proud of is at HP is that we not only have the products, but we also made sure that we have the capacity to deliver and run. So we want to make sure that alongside with our products, we are able to manufacture those systems, test them, integrate them, and deliver to you pre-integrated, pre-tested, so that you don't have to worry about the fact that the cluster is delivered without all the software tools, software optimizations, and whatever the ISV. Is that clear? ISV, so the independent software vendor? Yes? Okay, so everyone knows the ISV. Whenever we talk of ISV, that means independent software vendors. So we do all the pre-integration, and we deliver these systems to our customers pre-integrated and pre-tested. And you can be sure that this is appreciated by our customers, because their work is not to run IT. Their work is to develop products. Okay? What they want is a system that works. Now, this has been a trend that we have been seeing. If I start at the lower end, we obviously are able to build these clusters. Okay, so we have purpose-built servers, we have the software tools, and we have the cluster management utility that allows us to monitor and provision. So that's the build-to-order cluster. After that, we integrate the interconnects. Okay, so we work with whomever provides the best technology. For the time being, that's only Mellanox and Intel which is coming back. Okay, so Mellanox, we integrate the latest clusters, and for us, we delivered the first support for Blades on its system, and also top 500 system with the first system was with FDR with HP. Okay, after that, we integrate the accelerators, whether they come from NVIDIA or whether they come from Intel, and I will show you how we integrate those accelerators and how we do some additional work to make sure that your application will benefit of those accelerators. After that, we have the infrastructure. So that means that if you need to host your system in a specific environment, because it requires, I don't know, an external data center, we have the pods offering, okay, the performance optimized data center, and I will mention about that. And we also have extremely performing water-cooled systems. And this is also something that I will touch upon. And finally, and I will also disclose to you some details, we are completely and radically changing the way that we look at our HPC customers by providing low-power solutions or extremely dense solutions. And I will come back to that. Maybe some of you have heard about the Moonshot project or about the Apollo project. And I will have some words about it. But now let's move to our market share. At HP today, IDC recognizes that HP for the timing is the #1 company on the planet to deliver HPC. We are in front of IBM, we are in front of all the usual traditional players that you may see, T-Platforms, SGI, Cray, Google, name it. We are in front of all those guys. We deliver, and that's on the last top 500. On the last top 500, HP has delivered 190 systems out of the top 500. Is top 500 known to all of you? Yes? You know top 500? Okay. So we have delivered in the last release 190 systems. So coming in front of IBM by far, because IBM has only 160 systems. Okay? And you see all the others which are far behind. So what I would say is that at HP we have the ability to deliver many systems. It is an industrial provision, so we know how to deliver systems and we have the capacity to do so. Any questions or comments, by the way? No? Fine. Let's move on. So let's now come to some of the products, and I will not focus on all the products, I will only focus on a few products that are available. Some of you might be familiar with our blades chassis, which are very well known by the community. And this is the workhorse at HP, and we continue to develop this chassis. And we just have announced the availability of Ivy Bridge on this chassis and on the blades which are there. So this is the workhorse for many customers. However, this does not support accelerators. So this means that we will have to move elsewhere if we want to support accelerators. We then have the very traditional pizza box type, which is the EL line, okay, which probably many of you know. This is our HPC, or so-called HP hyperscale dedicated line, which is the SL line. And I will comment a little bit on that, because there's quite a bit of innovation going on into this line, and this is a dedicated HPC solution. Okay? And finally, I already mentioned about extremely low power computing solution, and this is our Moonshot product line, and I will comment a little bit as how this could be used for a certain number of your HPC users or HPC applications. As I'm talking to an academic crowd, I just would encourage you as academic crowds to consider the power usage of all the solutions that you are putting in. So we know that accelerators provide a good jump in terms of flop per watt efficiency. But with this solution, we are getting to a factor of 1 to 10 as opposed to a traditional x86 server. 1 to 10, so that means 10 times less power consumption. So if you have users that are constrained by power, then this might be the right solution. We will come back on that a little bit later. Now, let's move on to the SL line. So this SL line is comprised of Moonshot. This product, the SL2500, is going to be announced in 2 months from now, and is going to be a low-cost version of the SL6500, which is our HPC workhorse. I will comment a little bit about storage. Storage is becoming one of the biggest issues for all of you. If I read well, if you look, for instance, at a DNA sequencing machine, one single sequencer produces 3 petabytes of data per day today. One machine, one DNA sequencer, 3 petabytes. So you can imagine the volumes that we have to handle. So we have to come up with something creative to make sure that we can host all that amount of data. So this is going to be the SL4500